Today we're going to talk about how to understand your data, and specifically in the case of simple discrete data. And simple discrete, well, that's kind of a term that some people use, some people don't. But simple discrete, what we mean by it is there's only a few different values. So that wouldn't be something like the number of trees in each orchard in the world, because it could be 0, it could be 1,000,000. Like the example we're using here is points on a quiz. So the quizzes in this class generally are 6 points. So the possible values are 0, 1, 2, 3, 4, 5, and 6. There's only a few different possible values. And today we're going to talk about how to understand your data, how to visualize it, because if you look at our data here, 20 students in the class, these are their 20 grades on the quiz, you can't really just by looking at it see necessarily how the class is doing. Okay, so you can see, well, there's a few zeros, you see at least 2 sixes, so there's a wide range, but it's hard to tell what's most common, what the average is, that sort of thing. So when you're working with simple discrete data, there's only a few possible different values. What you want to do is just go through from left to right. The value is the number that it takes on, so the number of points in the quiz in this case. So what I'm going to do, I'm going to look from left to right. 0, I'm crossing out. I'm going to put a tally in the 0 row. Next one is 3, so I'm putting a tally there. 5, 0, 1, 3. And I'm going to keep doing this until I've taken into account every single grade on the quiz. When we do tallies, we have 4 vertical lines. The 5th one we cross out, so that in case we had like 20, we wouldn't have to count a bunch of vertical lines. We can count in groups of 5. Now that I've gone through and found all the tallies, I'm just going to count up how many tallies are for each value. So for 0, I have 6. So in the frequency column, I'm writing 6. For 1, 1 happens 2 times, so the frequency is 2. 2 happens 3 times, 3 happens 4 times, 4 happens 1 time, 5 happens twice, and 6 also happens twice. So frequency, this is the number of times that each score happened, and the number of students who got that particular score on the exam. Relative frequency, all that we're going to do to get relative frequency, divide by the number of students. You can think of this as like a percentage of students who got that score. So I made this so that there were 20 students total. So 6 students got a 0. So the relative frequency, 6 over 20, the decimal is 0.3. And I can just fill in the rest of these, 0.1, 0.15, 0.2, 0.05, 0.1, 0.1. Now, you might not have to do relative frequency. It's a good idea if your frequencies themselves are really high. Say that I had 1,000 students, I'm doing all of Shortridge here. Bringing it down to a percentage is easier to think about. And you can graph, you can display either frequency or relative frequency. The problem would just ask for one or the other. So now we have our frequencies. I'm just going to use frequency here, not relative frequency. We have our frequencies for each one. Let's show how to graph this in a plot. So always on the x-axis, going left to right, we're going to have what we're measuring. Our variable in this case is score on the quiz. 0 is the lowest, 6 is the highest. Each integer in between is a possible value. And on the y-axis is going to be frequency. So even though they both go 0 to 6, both the x-axis and the y-axis go 0 to 6, they mean different things. The score is the score that a student got. The frequency is how many students got that score. So let's fill this in. 6 students got a score of 0. So above 0, I'm going to draw a line at 6, and then draw it down, connect it down to the x-axis. This is like a bar chart. The book calls it a column chart. Same thing. And then 2 students got a 1. So go over, draw a line at 2, the y value 2, and draw it down to make a column there. 3 students got 2. So 3 students got a 2. 4 students got a 3. one student got 4, 2 students got a 5, and also 2 students got a 6. Okay, so now that I've plotted it out, I can see that, first a lot of students got a 0. That's not good, but maybe they were absent or they just weren't feeling it that day. 4, 5, and 6, not doing so hot, but that's still not bad. There's, 2 6s, 2 5s, and a 4. Not terrible. That's a quarter of the class got at least a 4 on the quiz. Not bad. One more thing we want to note about this graph is there's one statistical measure that you can tell really quickly, which is the mode. Mode means most common. I didn't know why it was called the mode, so I looked it up. In 1895, Carl Pearson, a wonderful statistician, wrote that he found it convenient to call it the mode. Okay, so it's short for maximum ordinance, the highest point. The highest point, which we call the mode, is the value that reaches the highest point. The highest frequency, in this case, is 0, because in our column chart, 0 is the highest frequency that happens. Okay, so that's this example, how to understand your data. Make a table with all the different possible values that happen, go through each time one happens, draw a tally mark, count up the tallies, and then if necessary, also do relative frequency, take your frequencies and divide by the number of students or the number of whatever you're measuring. So, looking at distributions here, this is looking at how the data could look, and these are sort of special cases, but a lot of things in real life do fall into these categories. I drew 3 different possibilities. We're going to sort of smooth it out, and so the first one looks like this. If you notice, it's not perfect, but basically from the mode, which is in the center, from the mode going left or right, it's the same. It's symmetrical. We call this a symmetric distribution. Symmetric distribution, left and right from the mode, is about the same. And so you notice the 2 sides, left and right, are about equal. It doesn't have to be perfect, it's just got to be close. In this one, in the middle here, let's draw this smooth line as well. It goes up over time and then it goes down pretty quickly. Actually, I can have it go down even a bit more quickly. It goes up over time and then down right away. So this one is called negatively skewed. And we call it that because on a number line, left is going to the negatives. So in this case, there's more on the left. Like if we split this right at the mode, there's way more to the left of it, way more to the negative side than the right. And another thing people might call this is left-tailed, which is sort of like, if you picture this as like a dinosaur, that's our dinosaur, it's facing to the right, but its tail over here is to the left. So it's left-tailed, the tail is in the negative direction, so it's skewed negatively or negatively skewed. Yeah, apologies for my weird dinosaur drawing, but hopefully that helps you remember that the tail is to the left. And the third possibility that we're talking about today, as you may have guessed, in this case the tail is to the right, in the positive direction, so this is positively skewed. So if we draw the smooth line as well, we see that from the mode, way more is to the right, which is the positive direction. As we go right on the number line, numbers get bigger, they get more positive. So this one we call right-tailed. If this were a dinosaur, the tail would be on the right side. Okay, one more thing from this section, which is called outliers. If you think about this word, they lie or they stay out of the main data. And there's a more formal definition for this, but let's just talk about what it means to be an outlier. So going back to our quiz example, let's say that Mr. Justin and I and Ms. Chia, we record the data in the gradebook, and we notice when we graph it, there's one way out here at 30. That is kind of weird. This is an outlier. It lies way outside where the rest of the data are, and so we might want to check that. We might look at the grade book and say, oh, I don't think it's possible to get a 30 on the exam. So we'll look through, oh, we actually meant to type 3, we just typed in a 0 instead. We typed in a 0 after the 3, that's why the outlier happened. Sometimes outliers happen because of bad data entry or bad measurement. Sometimes there are outliers. If you talk about, if you've got a class and you got one basketball player and it's Yao Ming, he's like 7'5" or something, he's going to be an outlier, and he is not measured incorrectly, he's just really tall. So outliers can happen. If you check it and it is correct, keep it. If you check it and it's like, oh, I made a mistake, it shouldn't have been there, you're going to get rid of that and you can make a note of that. So let's review. Trying to understand your data. If it's just written as a list of numbers, it's kind of hard to see. Put it into a table, make a column chart, make a column chart to see where the mode is, which is the most common, and see what the general shape is. If it happens to fall into one of these three distributions, then you can describe it as symmetric, negatively skewed, or positively skewed based on how it looks. And if you notice that some data point is way off, then you can go ahead and check that that is an outlier. Maybe it's legit, maybe it's not.